Hi, hopefully everybody had a nice holiday. Um, in the last video, at the end of it, I had some trouble um, with Mach 3 getting it to show what I was doing with the gear cutting. And if you're going to be using Mach 3 um, to kind of run your G codes and simulate them, I want to show you a few things to do. The computer that I'm using to do these videos on isn't the actual computers that are hooked to the machines out in the shop, so I failed to set them up to set up Mach 3 um, like I have the computer set up out in the shop. So it didn't want to actually show what I was saying, and it kind of messed up my video. So I'd like go into a few things first. Even if you're just using this to simulate your tool pass, you're going to have to set Mach 3 up, and that's what I failed to do. So in ports and pins, come into motor outputs, and you have to enable all the accesses. That's what I didn't do. Mach 3 was just installed with its generics, and it didn't have A access enabled, so that's why I couldn't get the actual tool path correct for my to show you the simulated gear cutting. So you'll have to come in and enable whatever axes you're going to use in your simulation. The pin numbers don't really matter. I just number them 2, 3, 4, 5, 6, 7, 8, and 9. Direction, low active, none of the rest of this matters, but they do have to have a step and a port. It doesn't do anything because it's not actually hooked to a real machine. Under, I believe, let's see, that's really all you'll have to do in the ports and pins one. Then click OK. Then click Reset. Then click on Config again and go into where it says Toolpath, and your toolpath screen needs to be set up like this. Don't worry about any of these numbers in the colors section, but you do have to enable A rotations enabled for the x-axis, and 3D compass, tool position, and show tool in Z-bar. Then once you've done this, then you can get it to display correctly. Now go ahead and go back into a wizard and pick one. I'm not going to pick the 100-tooth gear, but I'm going to try Newfangled Solutions. This is actually a registered copy, but it's the one I use all the time. There are other gear cutter ones like the one I showed you in the other video that are free. This is a $50 purchase here from Newfangled Solutions. So I'm going to click OK, continue. I'm going to pick my gear cutting. Now you can use this for a lot of different things. This right now is just tool information. I'm going to blow right through this because I really don't care. I just want a high feed rate. So just for demonstration purposes, so I could show a simulation. We don't want a simulation moving real slow. You sit there all day. So I'm just going to click continue at a high feed rate. Now it's asking where your actual tool and table is positioned. I've picked back left. Um, the actual fourth axis would be sitting on the left side, and the tool is behind the actual part. Uh, we're going to just go a distance of an inch. Let's cut 20 teeth on a 2-inch part. Want no Z move. You can turn this off and on. Once you're cutting a gear from the side here, you don't want anything to move your gear cutter up and down. I've got a total depth of 1/4 of an inch. I'm going to take, let's take 0.125, so we're making 2 passes to cut each tooth. And then, whoops, I'm sorry. This is my safe clearance before it rotates. I just back it out 10 thousandths past the material, let the fourth axis turn and go to the next tooth, and then we have 0.1/8 of an inch cut per pass for demonstration purposes. So I'll save the settings and post the code. Now when I exit and go back to Mach 3, I should get a good demonstration of what the actual toolpath looks like. Alright, this time we got it. I'm going to go ahead and click on toolpath to get the larger view and rotate this to the side, and now you can get a better idea of what's going on here. I'm going to go ahead and click cycle start to simulate it, and you'll see it make 2 passes. It's stopped for a tool change. It's going to make 2 passes per tooth and rotate. The way I tipped it's there you go. It's making 2 passes. I actually have it rolled up here. Let's set it down and roll it back over. It's going to roll and do the next tooth. And it'll just continue on until it's done all 20 of them and then stop. Now you can actually use the gear cutting software for more than just cutting gears. You can do it to use it to cut splines. I use it to cut the teeth out of the disc I make for the involute gear cutter. When I was saying I cut the profile into a disc for the tooth profile and make the involute gear cutter, then you can use this same software to separate that into, say, if you want 6, 8, 10, whatever cutting teeth in it, and come in from the top and actually, like a spline would be cut, and offset it and rotate it at a 7-degree angle and cut each one of the teeth and make your involute gear cutter. So I'm going to go ahead and shut this down and show you how the profile would actually be cut. First thing, I'm sorry, I'm jumping ahead of myself here. This profile that we took out of the gear when I drew it in the last video, what you can also use this for if you have a CNC mill, is instead of cutting a single tooth cutter for a fly cutter to cut your gear teeth, you can take a small cutter and in your CNC mill cut this shape into a piece of tool steel and use that as a form cutter in your lathe once it's been heat treated to cut the involute shape onto a piece of round stock. You also with a small cutter could cut this shape into like a thin piece of sheet metal to use as a gauge and actually manually cut this shape on your lathe and keep checking it with the sheet metal gauge you've cut out on the mill. So there's a lot of different uses once you have the actual profile. When you use a small cutter, obviously you're not going to get this exact sharp point right here up in the corner. That's not going to matter. A 1/16 cutter, as it came around through here, would leave a tiny bit of radius there. Makes no difference. All the teeth are going to be the same, and you'll end up with the same thing on your cutter for your small gear as your cutter for your large gear on a sharp point like that. So they will match, and it will, they'll still fit fine together. The main curve shape that you're looking for actually is from this point here to here. This is the bottom of the tooth, so it's not going to make that great of a difference if there's any discrepancy there, as long as they're all alike. Probably jumping around too much. So another piece of software I have is this is Lazy Turn, and it comes from Mach 3, and it's a program that comes out. They have Lazy Cam and they have Lazy Turn, and they're cam softwares that are you can use, but for the most part, when you draw something with them, you need to be careful. You need to actually simulate it, make dry runs on your machines first, and edit your codes. But I just want to show you how the actual profile for that disc to make the involute cutter would be done on a CNC lathe. So I'm going to open that file, and that's our 100 tooth profile to make our involute cutter. And as you can see, we have our profile laid out here on a 2-inch disc, and now I need to actually do the actual roughing passes and the fine pass. I need to select a tool first, so I'm going to select a sharp point tool. I'm going to do a roughing pass, and I hope I selected the right tool. That looks a little wrong. I'm going to say that I'm going to pull out a tenth. I don't need to pull out that far. Let's pull out 10 thousandths. And then I form my roughing tool pass. So I can go ahead and simulate this. Select it and simulate. Tell it to run. And you can get an idea how the machine pause it, speed it up. Kind of get ahead of myself there, but we'll see how this works. You can see how the machine would take out the roughing passes, and it'll simulate this. And you have to play with it, but at least you get an idea of what's going on. Now it's going to go ahead and cut the other side. It repeats itself. So I'm going to close this off now. And then I'm going to delete this one just because it would leave it in the way and it would block your view of the fine pass. I'll delete that tool path off. And then I'll show you once that the bulk of the material is removed, then the fine pass comes in and it actually follows the contour of what you're making. And I'm going to say a thousandths accuracy within 1,000ths. Per pass, I'm going to go 10 thousandths. Sorry. I don't know why I'm trying to go so fast here. It's causing me to mess up. Accuracy within a thousandths. And I'll have it generate the code for the actual fine pass. And you can see the difference is this pass is actually going to follow the contour of the shape and then smooth the edges. I'm waiting for it to generate the code for it. I should have set this blue line up here closer to the brown one. I'm showing more stock than I actually would have used, so it's having to generate paths all the way from out here. I don't know if you can see my X in. If I had to move this marker up closer to the brown one, I wouldn't have had all this extra tool paths in here. But now if I hit, let me regenerate this one. Tool path, delete the last one. Yes. We're going to make this 2.01 and hit OK. Alright, I brought that in closer. I don't need to generate that much tool path. Material's already gone because we took the roughing pass. So clearance, final pass, per pass here. Let's take, just for make it easier to actually view, let's take 50 thousandths off per pass. I wouldn't take that much on a finishing pass, but final pass it's only going to take 1,000ths off. So and we'll generate the G code again. You can see There you go. Okay, this time it's actually going to follow the contour, and I'll simulate that. I have to select the path and simulate, and you can see the difference now is instead of running just the z-axis to remove the material, it's actually following the contour of the shape. This is the part I'm saying you have to edit out. There's After it's done the roughing pass, there's no material where it's working right now. I guess you could have done the whole thing with just the fine passes, but $50 software, it's generating the actual code, just too much code. I only needed the last two final passes in reality, so I would go through this and edit it. There, as you can see, now it's inside following the actual contour. Now, if you look closely, and I can't really zoom in right here right now, but you could still see an actual gap in this section here between that last tool path and the part itself. I I have to select the tools that are in their list, and the tool should have been turned at an angle, so the point could have come in and address this more from the side. Like I said, this is a quirky piece of software, but since it does work and it works pretty well, here's where I'd use the gauge that I made out of sheet metal on the mill, and I would just come in and then work this by hand to actually just take this last couple of thousandths off of here, and then hold my sheet metal gauge up to it until I finally have it right. And you could even do it with a really fine file, work it the rest of the way down with a little bit of sandpaper, a little care. I mean, you can get the shape perfect actually. So, anyway, that's it for the simulation for what the lathe CNC code would be to produce the involute gear cutter. I see they had some requests for actually taking and drawing apart and then going from the drawing to the CAM software, eMachine Shop, and then finally taking that to the machine to machine the part. I'm going to go ahead and do that. I've got to look around and find something that I'd like to make in the shop. If not, the block of material is not that expensive. I mean, a $6 chunk of material, I could do a pretty decent part with a lot of different alignments and moves and stuff. So I'm just going to be a little bit of the planning stages, because that part will have to be the final part will have to be filmed with the video camera out at the actual machine. So I'm in the planning stages of that, and I will do a video of the completely making a part from drawing it, possibly even measuring it. Actually, do a video of measuring it and how I measure the part, replicate it, bring that to the drawing, and then go all the way through. So it is something I'm going to do. For now, just going to go ahead and shut down. I hope everybody had a nice holiday. Thanks for viewing, Steve.